All right, I thought I would do one last definite integral as a limit of Riemann sums, and this comes from an old textbook. Not an old textbook, an old test that I gave. And so what we have is use the formula a equals the limit as n goes to infinity. This a corresponds to the notation that was in the textbook. Basically, it comes down to this. Use the limit definition to evaluate this integral. 1 to 5, 1 minus x squared. So the first thing that I would do is get a picture of that interval. 1 minus x squared. Just a rough sketch. It doesn't have to be anything fancy. You can use your graphing calculator, whatever. It has a height of 1. Now, what's funny is that by the time it gets to 5, when x is equal, when x is equal to 1, this thing is 0. And then when x is equal to 5, the thing is negative 24. So the graph actually is all negative. It starts up here and goes like this. I think maybe I'm going to do some exaggeration here. It's a quadratic. So what I'll do is I didn't want a new window. I think what I'll do is take this one out of here and I'll sneak it in here, 1, and that way I can make the quadratic kind of just bend like so. Alright, the interval we're going is from 1 to 5. That means what happens is every time you do one of these rectangles we've been talking about, it's going to be, the height will be negative, so this integral will be negative. And what I like to do is draw maybe some, like a partition of some sort. And let's say this is x sub I, right here. Then we draw the right endpoint. By the way, this is by right endpoints is what was required. So what we would have then is the width. Let me take this over it off to the side. We have xi minus 1 xi. We have the thickness is delta x, and the height is f of xi. Or I think in this case I'm using the letter k instead of I. Not a big deal. So what is x sub I? Well, if you take a look, x sub 0 is 1. Then x sub 1 is equal to 1 plus delta x times 1. Delta xi equals 1 plus delta x times I. All right. So in order to do xi equals 1 plus delta x times I. Now, what is delta x? Well, remember, delta x is always the end of the interval, which is 5, minus the beginning of the interval, which is 1. 5 minus 1 over 4. 5 minus 1 over n equals 4 over n. So that's what my xi is 4 over n times I. So in here, then, what's the function? I will replace x with this stuff here. So I'll have 1 minus 1 plus 4 over n times I. Now it also cautions, don't forget the delta x part, which is the part that comes after the sum. This is squared. Let me make myself some more room in here. I probably should give my students more room to do this, but let's try again. I have 1 minus, and then I have x squared. That's 1 plus 4 over n times I squared, and then times 4 over n. So this would be the preliminary look of it. These are right-hand endpoints. That is what I believe was asked here. Right endpoint of each subinterval. Now, part 2 says that I want you to take this limit, evaluate this limit, to tell me what this integral is equal to. By the time you take this test, we'll actually be able to do this integral in a much easier way, but by the time you take it, you'll have that capability. I'll still want you to show me that you understand this aspect of it. So, let's go ahead and start the summation. I equals, actually I think that was using a K, so I'll stick with the same letter. Did I use an I? Yes, I did. In here, I have to change that to the letter K. So K squared. All right, let's go ahead and do that then. K equals 1 to n. 1 minus 1 plus 4 over n times I squared times 4 over n. Now with these, the first thing you ought to do is FOIL this piece out. This equals sum. I equals, I'm getting stuck with that I. I'll get it sooner or later. K equals 1 to n. 1 minus, now leave the parenthesis around it so you'll remember to take the negative through. So I'll have 1 plus, and when you FOIL this out, you get twice the middle term. So I have 8 over n times I, and then plus this term squared, plus 16 over n squared times I squared, times 4 over n. Now let me go ahead and multiply the negative through. Notice that the 1's will cancel, and I'll be left with negative 8 over n times I. This expresses the negative of the answer. Negative 16 over n squared times I squared times 4 over n. I'll go ahead and multiply the 4 over n through. And eventually I'll get this K thing down pat. So I have negative 32 over n squared times I minus 16 over n cubed times I. Nope, 4 times 16 is 64. Over n cubed times I squared. Now I'm going to break it up into a sequence of sums. K equals 1 to n. And I think I'm at the point now where I'm able to break this up pretty quickly without students being troubled too much by it. I should probably just go to I and forget about this K business. Okay. The formula for just K or I, whatever it is you plan on using, that's the one that's negative 32 over n squared times n plus 1 over 2 minus 64 over n cubed times n plus 1 times 2n plus 1 over 6. And in case you're wondering, scroll back up to the problem, and I give you the formulas up here, so you don't have to memorize anything. Now I'll do some simplifying. For instance, I can take the 2 into the 32 to make a 16. I can take an n out. I can take a 6 into 64 to get a 32 and a 3. And then I can take an n out to leave an n squared. So we have negative 16. You remember how, the thing that I do? I sneak the n under the n plus h, and I end up with 1 plus 1 over n. And then I have minus 32 over 3. And then I do the same kind of thing. The n squared. I'll have one n go under the n plus 1 to make a 1 plus 1 over n. And then I'll have the other n go under the 2n plus 1 to make a 2 plus 1 over n. Okay, and then the integral from 1 to 5, 1 minus x squared dx is the limit as n goes to infinity of negative 16 times 1 plus 1 over n minus 32 over 3 times 1 plus 1 over n times 2 plus 1 over n. And of course, the reason why I did this business with the 1 plus 1 over n is because the limits are extremely easy. 1 over n goes to 0. And we end up with negative 16 minus 64 over 3. So I'll make that negative 48 over 3. Negative 48 over 3 minus 64 over 3. And it looks like I end up with negative 112 over 3. I want to redo the last problem, but with left-hand endpoints. So in this situation, we'll look at the picture. We'll go, here's 1, here's 5. I think it'll be easier if I make these smaller. I'll go something like that. Now this time, when you start, there won't be a left interval at the beginning, but let's go ahead and do our markings here, like I'm partitioning it. Remember, 1 equals x sub 0 and 5 equals x sub n. So when I get to the one right before the end of it, it's x sub n minus 1. And then if you're doing left-hand intervals, at left-hand endpoints, you're drawing from the left, hitting the graph, and then going to the right until you complete the rectangle. So if I have, I think I found it was easier to do an I minus 1 here and to go from x sub I minus 1 to x sub I. Let's see if x sub I minus 1. If I do x sub I minus 1, then to get I equals 0, I'll have to run I equals 1 to n minus 1. I can't do that. I think, let's see, we have summation k equals, I usually did 0 to n minus 1 for these ones. F of x sub I, because this would allow the first thing to be 0. And then x sub, or 1 actually, x sub 0, this would allow us to have an x sub 0 to begin with. So I think it's probably better if I do an x sub I and an x sub I plus 1. Because then if I starts at 0, then the first x sub 1 is I plus 1. Let me grab this rectangle here in much more detail. First of all, the thickness is delta x. X sub I to x sub I plus 1. Remember, the graph comes here and touches the left endpoint. So the height is f of x sub I. And that makes sense because the very last time it'll end at n minus 1, which matches this. Okay, so what does x sub I equal? Well, x0 is 1, x1 is 1 plus delta xi. So let's see if this works for us. 1 plus delta x times I times delta x. Remember, doing k's. I'm going to try to do better this time. Times delta x. See, that's why I like to start this at 0. It matches the same format as all the other ones. So delta x is the same as it was before. It's 4 over n. Summation k equals 0 to n minus 1. F of 1 plus 4 over n times k times 4 over n. And let's see if that actually matches here. When k is 0, I am at 1. And then by the time k equals n minus 1, I am at this place here. Because my k will be n minus 1. That matches x sub n minus 1. That matched x sub k. So there we go. Let's go ahead and throw it into the formula. This is the summation. K equals 0 to n minus 1. 1 minus this stuff squared. Times 4 over n. As before, I'll FOIL this out. Okay, as before, a lot of the same things are going to happen. The negatives are going to cancel, or the ones are going to cancel. Tell you what, I can't believe how hard it is to break out of this habit. So I have negative 8 over n times k minus 16 over n squared times k squared times 4 over n. I'll multiply the 4 over n through. Summation k equals 0 to n minus 1, negative 32 over n squared times k, minus 64 over n cubed times k squared. And I'll break this into the sums just like I did before. So I have negative 32 over n squared, summation k equals 0 to n minus 1 of k, minus 64 over n cubed times the summation k equals 0 to n minus 1 of k squared. Now let me go ahead and use the formulas. This one starts at 0 and ends at n minus 1, so it only has n minus 1 non-zero terms. So remember, that changes the value of this sum. This sum is not n times n plus 1. It is now n minus 1 times n all over 2. And the same thing happens to the next sum, 64 over n cubed times n minus 1 times n times 2 times n minus 1 plus 1. All of that is over 6. And don't forget, this actually turns out to be 2n minus 1. Alright, so I'll simplify on n with the n squared. 2 goes into 32 16 times. 6 and 64, I can cancel a 2. Make that a 32, and then that a 3. Get rid of this n. And then play the same game I always do. Sneak this n under the n minus 1. So I'll have negative 16 times 1 minus 1 over n. Minus 32 over 3, and I'll do the same game. N squared, I can spread it between n minus 1 and 2n minus 1. See, the deal is, whether it's plus 1 over n or minus 1 over n, it's the same limit either way. So the integral from 1 to 5, 1 minus x squared dx equals the limit as n goes to infinity, negative 16 times 1 minus 1 over n, minus 32 over 3 times 1 minus 1 over n, times 2 minus 1 over n. And of course all those 1 over n's go to 0. I'll have negative 16 times 1 minus 0, minus 32 over 3 times 1 minus 0 times 2 minus 0. And I'll have negative 16 minus 64 over 3, which we had exactly the same thing last time. Okay, one last example in this, and I won't do any more of these, at least for lecture purposes, but I guess I will. If students have problems with homework or something like that, I'm sure I'll do more of these. Let's redo the last problem. Using midpoints. And of course these are always the most arduous. So I'll draw my picture again. And starts at 1, ends at 5. Try to draw this so that I can see it. I guess it ends there. All right. And then I'll put an x sub I minus 1. I think this one matched up best if I use the same kind of an interval as I did before. Remember, the rectangle you're making is based on the height of the midpoint. So the thickness is indeed delta x, but the height is f of xi minus 1 plus xi over 2. So how should we start this then? I think these were okay to start at 1 and end at n. Let's just make sure. I usually try to make sure that works at the beginning and the end. If this is x sub 0, and then I have an x sub 1, let's see what happens when I have f of x sub I minus 1 plus x sub I over 2. All right, so if, and I did it again, I did i's. I wonder if I did that on the previous problem. Like all these i's need to be k's. Like right here, same down here. So let's clean up a little bit based on what I did in the past. And just make sure I've got my case. Because I think all my pictures have the wrong kind of a picture. Here I should have an xk minus 1 and an xk. Now it's still the average of these points. So, and I'll go even to the beginning of this thing and see if I messed it up in here. I did. Okay. X sub k, all because I chose to use the letter K. Alright, let's see if I've eradicated k's. K, 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 K. K. Once you drop to n's, that's not a big deal anymore, so I don't have to worry about that. But now I've got my xk's fixed, xk's fixed. There's still an x sub I there. I'll make that into a k, if I can. K's, and I tried as hard as I could to be careful, but apparently I'm not very careful. Alright, good. Now I think I've got all my k's under wraps now. Now I've thought about the way of presenting this, and I think it might be easier to get these formulas, of course. What is x sub k minus 1? Well, what's x sub k? X sub k equals 1 plus delta x times k. Alright, then let's see if this works out. When k is equal to 1, I will be located at 1 plus delta x times 1, which is where I want it to be. X sub k minus 1, of course. X sub k minus 1 will equal 1 plus delta x times k minus 1. So, what I'll do with this, I think it's easier if I start k equals 1 to n, f of, I think it's easier if I take and do this 1/2, and then do x sub k minus 1 plus x sub k, delta x, and then let me go ahead and put in my numbers. Delta x is still 4 over n, so this will equal k equals 1 to n, f of 1/2. So x sub k minus 1 is 1 plus 4 over n times k minus 1. xk is plus 1 plus 4 over n times k. And then all of that times 4 over n. This equals k equals 1 to n, f of, I'm going to see if I can clean up in here at the same time as simplifying. So I'm going to do this 1/2 and sort of multiply it through at the same time. So if you see, you notice I have a 1 plus a 1, and half of that will be 1. Then I have 4 over nk plus 4 over nk. That's 8 over nk, but then the 1/2 will make that 4 over nk again. And then I have minus 4 over n, but the half will make that minus 2 over n. Let me pause a moment before I go any further to explain something that's going on here. You'll notice that most of our stuffs have k attached to them. Some of them just have a number, and some of them have an n but no k attached to them, etc., etc. What happens is the midpoint method is something of a mixture of the left and right hand method. As you can see, it's actually taking the left and right hand endpoints and taking their mean. That means you're going to have collateral stuff left over from either one of those. That's why some of these things, when we get down to it, you'll see things that'll just turn out to be 0 and have no bearing. It's because of the overages and underages. Sometimes they get so small as to be insignificant. But anyways, let me go ahead and plug this into the formula for f. So I get the sum k equals 1 to n. This stuff goes in where x was. So we have 1 minus, and it's that stuff squared. So we have 1 plus 4 over nk minus 2 over n squared. And then outside of that, 4 over n. Then sum, I wasn't quite ready for that, equals the sum k equals 1 to n. I'm going to FOIL this out don't forget to put your minus. Start yourself a parenthesis so you don't forget that it's going to apply to all the things inside of here. When I do the 1, I'm going to have to do 1 times itself. Then I'm going to have to do 1 times 4n over k, 4 over nk, and then I'm going to have to do 1 times negative 2 over n. And then I'm going to have to redo the whole thing with 4 over nk. So I'll start with 4 over nk times 1. And then I'll start 4 over n times k times 4 over nk. So that's 16 over n squared times k squared. And then negative 4 over nk times negative 2 over n will be negative 8 over n squared times k. And finally, the negative 2 over n will come through and multiply everything. So negative 2 over n times 1 will be a negative 2 over n again. I'm kind of doing this so I can keep track of everything. Then negative 2 over n times 4 over nk will give us negative 8 over n squared times k. There it is. And then finally, negative 2 over n times itself will be 4 over n squared, and I don't see a spot that that's at yet. I probably should make this huge, and this one huge, and take this one and put a bracket here, here, and I will sneak ever so gingerly a 4 over n over there. And let me simplify. Summation, oh, look at that I sneaking in again. I can't believe how potent that thing is. K equals 1 to n. 1 minus, let's see what we have in here. There's 1. Then these 4 over nk, so I have plus 8 over n times k. Then I have negative 4 over n. And then I have plus 16 over n squared times k squared minus 16 over n squared times k plus 4 over n squared, end the parenthesis, do the bracket, 4 over n. I'm not really sure. I mean, I'm going to come through and change all these positives and negatives and vice versa, and I can take out the 1s. So I have the summation k equals 1 to n. Let's see, we have negative 8 over nk. We have plus 4 over n. Minus 16 over n squared times k squared. Plus 16 over n squared times k. Minus 4 over n squared, and then end the bracket 4 over n. Let me just check, make sure the 1's got out of there. Negative in front of the 8 over nk, positive in front of the 4 over n, negative in front of the 16 over n squared k squared, positive there, positive there. Let me go ahead and multiply the 4 over n through. So summation k equals 1 to n. I'll have negative 32 over n squared k, and then I'll have plus 16 over n squared, and I'll have negative 64 over n cubed k squared, plus 64 over n squared n cubed k, and then finally minus 16 over n cubed. Now, what I was talking about, I'll tell you before I get into it. This here will actually contribute to the answer. This here will come out to be 0. This will contribute to the answer. This will not contribute to the answer, and neither will this one. All of those will 0 out. You'll see what I mean when I do them. I'm going to go ahead and break these up then into the the individual summation. So we have sum k equals 1 to n, and I keep doing that to myself. I want negative 32 over n squared, put a k here, plus 16 over n squared summation k equals 1 to n of 1. Then negative 64 over n cubed summation k equals 1 to n k squared, plus 64 over n cubed summation k equals 1 to n of k. And finally, negative 16 over n cubed summation k equals 1 to n of 1. Alright, let's see what we have then. For the first one, the formula for that particular sum, negative 32 over n squared, is n times n plus 1 over 2. Here the summation for this is simply n. Then I have negative 64 over n cubed. And the formula for the summation of k squared is n times n plus 1 times 2n plus 1, all of that over 6. Let me fix that plus. And then I have the formula for k. I'm going to have plus 64 over n cubed times n plus 1 over 2. And finally then I'm going to have negative 16 over n cubed times n. And let's go ahead and simplify where I can. So I can cancel this 2 into 32. That leaves me with a 16. I can take out an n here with that. I can take out an n here and here. I can take out an n here and make that into an n squared. Cancel 2 out of the 6, make it a 3, and make the 64 into a 32. I can take an n from here and make that into an n squared. The 2 goes into 64 32 times, and I can finally take an n out of the 16. Alright, let me simplify. Let me rewrite it with the simplifications made. Remember, one of the things I do with my n is I put it under the n plus 1. So this first piece will be negative 16 times 1 plus 1 over n. Then I have plus 16 over n. Now I have an n squared. Remember, I evenly distribute the n squared between the n plus 1. One n goes under the n plus 1, and the other n goes under the 2n plus 1. So I end up with negative 32 over 3 times 1 plus 1 over n times 2 plus 1 over n. And then I have plus 32, well this n I can bring underneath the n plus 1, but I still have a 32 over n times 1 plus 1 over n. And then finally I have negative 16 over n squared. Now that is a lot of stuff, so I'm going to say now let n go to infinity, and we end up with, I'll just kind of put this in a little bullet point here. So this will be negative 16 times 1 plus 0. This piece will be 0. This piece will be negative 32 over 3 times 1 plus 0 times 2 plus 0. Plus, now here, this is interesting. While this will go to 1 plus 0, this part will go to 0. The 32 over n will become 0 times 1 plus 0. And then this will become 0, minus 0. And we end up with negative 16 minus 64 over 3. And if I'm not mistaken, this is the same answer we got for all the other ones. let me go back and check. Negative 16 minus 64 over 3 gives us our negative 112. So the integral from, what was it, 1 to 5, 1 minus x squared dx equals negative 112 over 3. And I've gotten the same answer for all three of them, so I feel pretty good about it.